All right, file and directory permissions. This is a very, very important concept in a Linux environment. And if you do an ls-l to get a long listing, you'll see output that looks like this. You've seen me do that a number of times, and this is similar output. The very first character that you see in each line of this output indicates whether the item you're talking about is a directory or a file. If you have just a hyphen or a dash there, that means it's a file. If there's a letter D, that means it's a directory. So you can kind of ignore that first character. It's not very useful. The remaining 9 characters define the permissions that have been assigned to each file or directory. The first 3 characters refer to the permissions associated with the owner of the file. That's you, the person who created the file. The next 3 characters refer to the permissions of the group that the owner belongs to. The last 3 characters refer to the permissions for all other users on this system. And there are only 3 types of permissions you can have. You can have read, write, and execute. With read permissions, you can read a file, you can copy it. With write permission, you can edit a file, and you can also delete it. And with execute permissions, that just means you can run it as a program. And these different permissions are assigned using the chmod command and this 3-digit octal notation. The 3-digit octal notation is used because each of these 8 numbers represents a particular combination of permissions. And each of those numbers refers to the permissions being assigned to either the owner, the group, or all others. So in this example in the slide, I'm changing permissions on this text file. I'm changing permissions so that the owner, myself, will have full read, write, and execute permissions. And then the group that I belong to and all others will only have, they'll have no permissions at all, because 0 refers to no permissions at all. So in a way, I'm locking this file down so that only I have access to it. And that's done with the chmod command. Now, if you want to share a file with someone else in your Linux system, the chmod command you'll typically use is something like chmod 755 or 744. That way you'll be giving somebody else access to the file, but they won't be able to modify the original. So they can read it, they can copy it, they might even be able to run it, but they won't be able to change the original at all. So chmod 755 or 744 is typically what's used. And don't forget, if you change permissions on a file so that someone else can access it, you may also need to change permissions on the parent directory, because if they don't have access to the directory at all, they can't access the file you've shared with them. All right, this is a very, very quick example of compiling a program and running it from the command line. So again, I'm in my intro-linux directory, and there's a C source file in there called pi.integ.c. And that's a very simple little C program. And understanding what it is not really important for this course, but it just calculates the value or estimates the value of pi using numerical integration. But we're going to compile that program and run it. First of all, every programming language that you use has its own unique compiler. There's a C compiler, there's a C++ compiler, there's a Fortran compiler. And what I'm going to use, since this is C code, see it ends with a .c extension. Again, extensions are optional, but I do this just to make it clear for myself that that's C code. Since it's a C program, I'm going to use a C compiler. And the one I'm going to use is GCC. If I use GCC and I type version, I can see which version of the GCC compiler I have available to me. I can even use the which GCC command, and that shows me exactly where the GCC program is located. It gives me the full path to the GCC executable. Now, to compile my program, I'm going to type GCC and the name of the source code, and I can type -o to specify an output file. In my case, I'm going to call it pi.integ.exe. Typically in a Linux environment, you won't have a file name extension for executables. It's completely optional. And I'm just using it here to make it clear. But you can use any name you want. And if you leave that off entirely, by default, the executable will be called a.out. But like I said, I want to specify a name for mine, and that's what it'll be. And so I run the compiler, and that's it. It was really, really fast because it's a very small program. If I, again, do a long listing, sort by time and reverse the order, there's my new executable that I just created. To run my executable, if I type py.integ.exe, of course, it's not in my path, so the command is not found. I need to tell bash to run it from right here. So ./py.integ.exe. And it asks for the number of intervals. And if you're running this program, you may want to use a very small number here, because if you use a large number, it'll take a very long time. I'm going to specify number 5, and then it estimates the value of pi. It gives me kind of a bad estimate of pi, because I only used 5 intervals. And that's it. That's compiling and running code from the command line.